Hey guys, how you doing? It's Coach Scott again, and let's do another little episode of Red Devil Chemistry. Right, we're continuing to work on Worksheet 4S right now. Right, Worksheet 4S. So what we need to look at now is problem number 3. What is the mass in grams of 0.531 moles of 10 SN? Of 10 SN. So first of all, we got to get our periodic table, right? Because that's going to give me the atomic weight of 10. Let's start it off with, we've got what, 0.531 grams of SN, 10. Now if I look at the molar mass, the atomic mass, right, I'm going to put this down in the denominator, grams SN. 1 mole of SN equals how many grams? 118.71 grams. All right, now we take our calculator out. We take our calculator and very easily 0.531 divided by 118.71, and that's going to give me okay, and I'm going to do this in scientific notation. 4.47 times 10 to the minus third moles. Ooh, I didn't do that right, did I? No, I didn't. And this is why that didn't make sense, right? Because we got 0.531 grams. I didn't do my numbers right here, did I? So I've got moles of SN. So that was a mistake on my part. So now we've got to switch this around. Use a green one. All right. That didn't make sense. And in chemistry and in anything really, when you get your answer, just don't do what the calculator says. I did, right? I did put what the calculator said, but it didn't make sense. That's why I had to rethink that. So now that's moles of SN. So I'm going to put 1 mole in the bottom so I can cancel out the moles. And I'm going to put the atomic mass of 10, and that's in grams. So now if I take 0.531 and I multiply by 118.71, I get 6.30 grams. So that's not the answer. 6.30 grams. Excuse me, 63 grams. 63.0 grams. Because my calculator said 6.30. And then I say, oh, it's got E to the first, so I got to move over to the right. So I'm just going to do that. 63.0 grams of SN. Let's hope we don't make that mistake again. So how many moles of calcium are 2.03 grams of calcium? Set the problem up the same way. 2.03 grams of calcium. Get that right? I do. Alright, so now I need to find the molar mass of calcium, and it is 40.08 grams. 40.08 grams of calcium in 1 mole. 40.08 in 1 mole of calcium. Okay. So now I just got to do my math. Let's see how I cancel out the grams. Alright, so let's do that. 2.03 divided by 40.08. And I get, looking for moles, I get 5.06 times 10 to the minus 2 moles. Or I can go ahead and put that into regular numbers, and that would be 0.0 equals 0.5. Now I got to put 3 sig figs, 0.7 moles. Or I could write it like this: 5.07 mole times 10 to the minus 2 moles. Either one would be correct. So we got the first 2 problems going, and we're still cooking along here. All right. Don't have my timer now. Let's look at the fifth and sixth problems. Fifth and sixth problems. All right, so I've got 5 moles of binary acid. 5 moles of binary acid. Okay. And its group 2 oxides are found to have a mass of 521 grams. Identify the group 2 metal. All right, identify the group 2 metal. Let's see. So I've got to use some sense here, right? So it's 5 moles of a binary, that means 2, group 2 oxide. So it's got to be one of these in group 2. Okay? And it's an oxide, so it has an oxygen, right? So if I look at oxygen, it's -2. Group 2s are +2, so it's going to be 1 oxygen, and I'm going to put XO. X would be the group 2 metal, right? It's not XO2, it's XO. Now I know that oxygen has a atomic mass of 16 grams. There is 5 moles of this, right? And we know that the total mass of the 5 moles of the binary group 2 oxide has a mass of 521 grams. So that means I have 1 mole in the oxide, right? 1 mole of oxygen, but I have 5 total moles. So I'm going to have to multiply 16 times 5 because I have 5 moles, right? So 5 times 16. All right, and that gives me 81. 5 times 16. Does that make sense? 32, 64, 32 and 64, and another 64 and another 16. Oh, 80. That would be 80 grams, not 81. You gotta be careful what your calculator says. So that is 80 grams. So I need to find out what the 5 moles of the oxide is. The total is 521 grams, and that's the 5 moles of X and O. All right. So that means his oxygen is worth 80 grams because that's the 5 moles of oxygen. If I do 521 and I subtract 80 grams from it, I get 441 grams. Now, if I went ahead and started looking for that, I'm not going to find it. There's not an element on here that weighs 441 grams atomic mass. However, if you recall, there's 5 moles of oxygen. That means there's 5 moles of the other one, of the group 2 metal. So if I divide 441 by 5, that's going to give me 88.2 grams. Why did I do that? Because there's 5 moles of metal there. There's 5 moles of oxygen, 5 moles of metal. So I come up with a atomic mass of 88.2 grams. Now, if I look at my periodic table, I've got to use my sense here. It said it was a group 2 metal. Group 2 metal only. Group 2 metal. So now I've got to find the group 2 metal that is closest to 88.2 grams. And if I look, I see that strontium has a mass of 87.62. So my answer, what I'm going to block in, is SR, strontium. We can knock out 6 real quick too. So how many tantalum atoms are found in a 1.23 gram sample of tantalum? So now we're going to use a couple of concepts here. So I got 1.231 grams. So I've got to get it into moles, right? TA. So tantalum, right here, element number 73, has a mass of 180.95 grams, TA, in 1 mole. And I'm going to do this step by step. Alright, so if I take 1.231 and I divide by 180.95, I'm going to get a number of moles of 6.81 times 10 to the minus third moles. So I know that 1 mole, let's put this over here, 6.81 times 10 to the minus 3 moles. I know that 1 mole of anything, we're going to say tantalum, has the number of, it's looking for atoms of 6.02 times 10 to the 23rd. So if I take that and I multiply by 6.022 times 10 to the 23rd, I should get my answer. Alright, and I do. See if that makes sense. 0.06802 times, what do parentheses? 0.022 23rd. Yes, I get 4.096 times 10 to the 21st number of moles. Let's make sure that makes sense. Yes, I had a 1.231 gram sample of tantalum and 180.95 grams divided by that gives me that. Multiply by the number of moles, or the number of atoms in a mole, that's what I get. Okay, that would be 4.096 times 10 to the 21st. Look at the sentence, the next one. What is the mass of 8.11 times 10 to the 23rd atoms of sulfur? Alright, let's write down our known. 8.11 times 10 to the 23rd atoms, similar to the other problems. Alright, we've got to get it into moles. Alright, S. So there are 6.022 times 10 to the 23rd atoms in 1 mole of sulfur. And if I do the math on that, 8.11 23rd, alright, divided by 6.022 23rd, I get 1.347 moles of sulfur. So I've got 1.347 moles of sulfur. Alright, it asks for mass, so I look on my periodic table. 1 mole of sulfur has, let's see, 32.06. Alright, times 32.06. And I get 43.18 grams of sulfur in 8.11 times 10 to the 23rd atoms of sulfur. I think we got time for 8. Let's get these. These are pretty easy. Let's see. What mass of copper atoms have the same number of atoms as are in a 4.21 gram sample of silicon? Now I've got to think here. I've got to get the number of moles, right? So if I got a 4.21 gram sample of silicon, all right, and I look at my atomic mass of silicon, that's 28.09 grams of silicon in 1 mole. And that's going to give me the number of moles, right? 0.21 divided by 28.09, and I get 0.1498 moles of silicon. So it asks for the same number of atoms as there are in 4.21 gram sample of silicon. So really I'm asking for the same number of moles, right? Same number of atoms. So if I've got 0.1498 moles, 1498 moles of silicon, okay, the same number of atoms is going to be at 0.1498 moles of copper. So I have 0.1498 moles of copper. All right, the mass of that is going to be in 1 mole. I look at my periodic table, copper is 63.55. Move that up a little bit. 63.55 grams of copper. 1 mole copper. All right. 0.1498 times 63.55. I get 9.52. 9.52 grams of copper. And what that means is it's going to have the same number of atoms because the moles are the same. Okay, guys, that's one. I don't know, 3 through 8 on worksheet 4S. Hopefully that helps you guys out. We can talk about those if we need them, but other than that, Coach Scott, Red Devil Chemistry, out.